So there we discuss about the MRP, Marginal Revenue Product, and the cost of the production factor. So finally we said the optimum employment of the production factors will be at the point where marginal revenue product equal to the production factor, price of the production factor. That is the point we stopped in the previous class. With that, we can do one more exercise, then you will be having a better idea. So I had put it there, probably some of you have done that at home. So here, the production function is given as Q equal to 60L minus L square. Now, is this a short run or a long run production function? This one, is it a short run or long run production function? How to check that? So we assume that output is a function of capital and labor. So we put like Q equal to F, K and L, which simply says output is a function of capital and labor. Output depends on the variation in the capital and labor. But in this function, this is the functional form, this is the mathematical form. If you look here, there is no K terms, which says that K is fixed, right? The production will be totally determined by labor. There is no any K. Right? K probably could be the 60, which is included in the efficiency parameter. Right. Therefore, this is a short-term production function. We have only labor. So short-term production function is given. Price is given as 6. Wage is given as 16. Now, find the optimum labor rate. Calculate the profit of this firm at the optimum labor rate. So, given these conditions, this production function, price of good, and the cost of the factors, find the optimum labor rate for this institution. What is the optimum labor rate? Now we need to decide how much of labor that we should recruit to the institution and profit at that time with the optimum labor rate. So I will give you 10 minutes. Now it is 8 past 23. So we will get back at 8 past 33. If any questions you can raise, I will be here. While you are doing that, I will be taking someone randomly for the answer. So therefore, start the calculations. So the short-run production function is given and price, the price of the output as well as the cost of the production factors. Where we are having only labor, therefore wage is given as 16. So what is the optimum labor rate? What is the optimum labor rate? This is same as what we did in the previous class. Anyway, now how to get the optimum labor rate? Simply, what is the rule? What we did in the previous calculations and what did this graph say? It is simply not worry. Whenever you get this kind of a problem, check the question. Right? Check the question, what that question is asking. So it has given us the production function, prices of the output as well as wage, and asking find the optimum labor rate. How to get the optimum labor rate? So we know this is the condition. Right? The condition for optimum labor rate is MRPL equal to W. Marginal revenue product equal to wage rate. Now, we need several things. If we are going for that, we need the wage rate. And MRP, which is equal to MPL multiplied by P. So we need price. We need wage. Both are given. And we need marginal product of labor. So we need to get marginal product of labor. And here we are having price is given, wage rate is given, and the production function is given. Which is not given here directly is the marginal product of labor. And then how to get the marginal product of labor? We learn how to get the marginal product of labor, that is del Q by L, or dQ by dL. Simply let's say dQ by dL, which says that the first order derivatives of the Q function, this one, with respect to L. Right. Then we get MPL. If MPL multiplied by price, we get MRPL, which is equal to 16. We just equalize those two, then we will get the optimum labor rate. So I have done it here. So these are given. Output is a function of labor. The functional form is given as 60L minus L squared. Price is 6, wage is 16. So therefore, first what we have to calculate, we need to get marginal product of labor, because marginal product of labor is not given directly. But we know that can be calculated with the production function, with the derivatives. So simply, MPL or marginal product of labor equal to 60, because this is L power to 1. So that is 1 minus 1, which is L power to 0, equal to 1. So 60 multiplied by 1, it is equal to 60. Minus, we take this to the front, that is 2, L, 2 minus 1, which is equal to L power to 1. So therefore, in this case, MPL will be this one. MPL will be 60 minus 2L. So then we need MRPL. How to get the MRPL? That is MPL, this one, multiplied by its own price, the price of the output. And if you multiply this one, you will be getting something like 360 minus 12. So this is the MRP. Now MRPL equal to W. Therefore, we can set this equal to 16 and solve that. If you solve, you will be getting L equal to 29. So anyway, let me explain this one first. So what I did, I got MPL and MPL multiplied by its own price. Then I get MRP equal to 360 minus 12L. Then we should equalize this to 16 because MRPL equal to W. So when we put MRPL equal to W, we get the answer L equal to 29. So the final answer, optimum labor rate is 29. So now we know that. And one question, not one question, suggestion is there, that is to explain how to get the MPL. Right. So production function is given as 60L minus L square. So this is given. Right. This is the functional form of the output function. Right. Q equal to 60L minus L2. Then we need the marginal product. What do we mean by the marginal product? Marginal product is the value for the next labor unit. When we increase our labor by 1 unit, right? When we increase our input, that is the labor, by 1 labor unit, what's happening to our output? That is what we mean by marginal product of labor, because as I told you some times ago, marginal means in economics, that is the value for the next unit. Right? Therefore, we can get the help of the differentiation. If we get the derivatives, of course, that tells us the rate of change. When we change L by certain amount, what is happening to our total output? That is given by the derivatives. So what we can do, we can put dq by d. Simply this is delta q by delta. So it says what is the change in L, and due to that change, what is the change in Q, or the total output. That is what we really interested. Therefore, we can take without any harm dq by dl to find the NPL. Then what I said here, when we learn the derivatives, we learn that we can take this constant forward without doing any calculations, and then we are having L power to 1. Here 1 is there, we never care about that. So if you are worrying, you can put 1, L, 1 minus 1 minus, we can take this forward, 2 L, 2 minus 1. And so the remaining will be 60 multiplied by 1 multiplied by L, 1 minus 1, L equal to 0 minus 2 L 1. And then we don't write 0 or 1 because L power to 0, which is equal to 1. Therefore, this should be 60 minus this part. We never put L power to 1 because we know already it is there. Therefore, MPL equal to 60 minus 2L. This is how we got the MPL. The calculation part up to L equal to 29 is clear. Then calculate the profit of this firm at the optimum labor rate. What is the profit at the optimum labor rate? Profit. Now we know optimum labor rate is 29. This firm should hire 29 labor units given the price of the product and the wage rate. Of course, when you change the wage rate and the price of the product, this may change. But given price and the wage rate, this firm should employ 29 laborers or labor units. Then that would be the profit maximizing output level this firm would take. We are not going to calculate the optimum output level, but profit can be easily calculated. What is the profit of this firm? So how to get that? That is very simple because we know the production function. Right? Production function equal to 60L minus L2, L power to 2. Now we know L. What is the employment of labor units? What is the number of labor units that we should hire at the profit maximizing output level? So we can find the output level easily by substituting the value of L into this function. That is 60 multiplied by 29. This is the number of labor units at the optimum point, and then minus L power to 2, and which is 29 power to 2. If you solve that, your total output will be equal to 899. That is the output level given the price and the marginal product. Then to get the total revenue, we can easily do that because we know the output level. Output level is 899. If output level is 899 and the price is 6, then easily we can get the total revenue. Total revenue will be 5,394. That is what I calculated. Probably if you calculate, you would get the same. If you get a different number, please let me know. There can be some calculation errors even from my side. But anyway, total revenue equal to 5,394. Then how to get the total cost? Total cost equal to, now we know the labor units at the output level, optimum output level, number of labor units is 29 and the wage rate is 16. Therefore, total cost will be 464. And TR minus TC equal to 4,930. Right. So this tells that given the price and the wage rate and the production function, this firm will produce 29, this firm will use 29 labor units. Using 29 labor units, this firm can produce 5,394 output units. At that time, profit of the firm will be 4,930. Now the question, what is this profit? Profit, probably let's forget about that question for the moment. Towards the latter half of the class, we will discuss about the cost function. Then I will raise the question again. For the moment, just remember, because we did not do the accountant cost yet and the economic cost yet. But simply this tells us this is the profit. So given the number of labor and the price. So when you have free time, you can change some of the variables. You can increase the wage and see what will happen to the profit and what will happen to the number of labor units that we should employ. Or you can change the price. When you change the price, check what will happen to your output level and the profit and so on. Right? So do that when you have a free